Look, I start with a confession, actually, and I'm doing this to the right crowd. I think, I have developed a fairly intimate relationship with ChatGPT over the past months, and I've mentioned that before, and I'm sure you've discussed it today already. And I asked it, actually, what type of title should I put forward? And it gave me some 10 titles, and that's the one I chose. And that's the one you're going to get today. And, it's the one which also told me how to structure the presentation. So today, what you're going to get is probably the first human narrated presentation on 6G, okay, with what AI actually wants me to talk about, okay? So here we go. And the presentation itself is structured really in three parts. The first part, I'll a little bit discuss the journey, how currently 5G is playing out and what are the exciting applications we see. And then that lays the ground for why we need 6G. And then the last part is going to be really about some techno policy issues. In fact, I wanted to talk with you guys about not only, technology, but also policy, because King's is a very strong policy institute. I used to work with them quite a lot, and I do encourage everybody who's on the call from King's College London to reach out to the Policy Institute and really work on this. Some really big questions which are still open. And not surprisingly, quite a few of those actually related to artificial intelligence. So let's get going. On the road to 6G, really, what is currently, rock and rolling here? I work for a boutique engineering shop called Ericsson. We are engineers. We like to build things. So we built this, what we call a holotowering solution. So you see Ezra here, this lady, she's plugging in a volumetric capturing device, which is able to really understand in real time the point cloud, of her presence, and that's being transmitted in real time to the other lady who's seeing her in the Nreal augmented reality glasses, and she sees her anchored in the chair, right? And as she moves her head, Ezra would remain in the chair. So therefore, we wanted to get a feel. What does it mean to understand, spatial compute? How do we understand occlusion? How do we understand spatial anchoring? What does it mean from a data rate point of view? What does it mean from a latency point of view, jitter point of view? So we've got a lot of insights there. Of course, Ericsson will never sell this as a solution, but we wanted to understand what does it mean if data goes over the wireless internet, and how did that mention the networks? And in the meantime, I've just come back from Mobile World Congress, and I was really on the scout for some consumer grade augmented reality glasses, because the ones you see in the video, the Nreal glasses, they're all great for enterprise, fantastic, but as a consumer, you wouldn't walk around in this clunky thing. So I'd like for something which is a little sexy, and actually, I would put it on. So the sunglasses I use here in California look like this. Okay, let me just put them on so you can see that. So this is the type of stuff I was looking for, right? So something which could either be as light as this one or my normal glasses. I'm getting older now. I need to use glasses when I look at the screen. Anyway, so I found the Vuzix glasses, and Vuzix has been around for quite a while. You see it here. You see it here on the screen, I hope. So I tried them on. Fantastic, really great quality. It's a pretty good glasses, I think, for the first type of consumer effort. So, but then we kind of, as Ericsson, we're like, okay, so we build it. It seems to be quite a useful solution to some of our engineers. But is there actually demand? And that's always the big question, right? Is there demand? So, and one thing Ericsson does pretty well is to reach out to consumers around the world. And we have just queried in 2022 about maybe 40,000 people and asked them, if AR was to come about, how would you use it and where would you use it? Okay, so and the how is shown here on the horizontals. So you see applications which are more than 1 hour a day, just about an hour a day, and very, very infrequent, right? So, and then where is, at home, in work and school, and then the wider area when you're kind of roaming about. And, the at home and work school, there's at home definitely is Wi-Fi. And, the majority of the world's traffic will always be carried by Wi-Fi. But when you're at work, at school, you may want to use Wi-Fi, you may not want to use Wi-Fi. I don't use, for instance, the Wi-Fi network on my mobile phone here at work. Also, when I was at King's, I've never used King's Wi-Fi on my mobile phone. And of course, you don't use Wi-Fi as you're in a bus, on a train, or you're walking over Waterloo Bridge, whatever, So therefore, the red column is really interesting to us because that is where the wireless networks, the cellular wireless networks really make a difference. And so consumers are quite excited. And we mapped a few of these applications into, what they would use it for. So the top one, social media, think of Snapchat, think of TikTok, right? So overlays, you have your glasses on, Snap has developed new glasses. You put it on and you see essentially what you would normally see on Snap with the AR filters. You see it right in your augmented reality glasses, right? You could have more immersive messaging, gaming, etc. I'm super excited about mobile shopping, I have to admit. I really struggle with the gigantic shopping malls here in the United States. If ever I go on a shopping trip, this is like a whole day event for me. If I had glasses which guide me actually straight to what I need to buy, and the back end is synchronized to the actual store I am. Look, I'm willing to pay for that. So this is like, I would probably not use it like an hour a day, but you would use it, that would provide real value. So, no matter where you are there, the majority of the applications, have an AR overlay element. So there seems to be demand, which is great. So we settled demand. Now, how do we think this with the current demand predictions? How could this actually work out over the next year? So we think the next 1-2 years will really be kind of a mixed reality era. We'll still have VR. We will have AR emerging. We have some mixed reality glasses, and we really hope that some of the leading vendors, and I'll come to this in a moment, will release essentially their mixed reality glasses, to be confirmed. But then we believe as time goes on, 2025, 27, augmented reality will really take a lead. The glasses will become lightweight, and we will have fantastic tools like Niantic. Niantic's behind Pokemon Go. Probably you have heard about Pokemon Go. So the company behind this is Niantic. Niantic has just released a lot of really interesting content. A Marvel experience. They're releasing something, an NBA experience. They're releasing something in May, a really cool game. And they acquired a company called 6D.ai, which actually was run by a friend of mine here in San Francisco. What Matt, my friend, has managed with 6D.ai is to really, develop this spatial anchoring capability. And so basically his tool set allows Niantic now to really understand where objects, how is the occlusion working, how do you spatial anchoring, how can you implement then the physics on that. So it becomes a really immersive experience towards this next generation internet we're building. And the tool set is called Lightship. That's a Lightship development environment. So if anybody wants to try it out. And then as we go towards the end of the decade, we will have a fully immersive society, holographic society, with hopefully, fantastic kind of immersive experiences, and of course we don't have a crystal ball, but we hope that this will work out in one way or another. Now, in terms of companies, if you look at the market area, and I want to give you a bit of an industrial perspective there as well, as you always have to think about a quadrant of like 4 major, players. The first one is the market enabler. And in the AR, VR case, this is really Qualcomm. So Qualcomm has been building a fantastic set of chips and spatial compute capabilities, which allows essentially a lot of the other players, content providers, to play around with reference designs and really build these solutions. Then we have the market challenger, and then in this case would be Meta. Meta is, has a good footprint in over-the-top applications like Instagram and Facebook and all that. But they don't really have that footprint in terms of devices and really, having that control on the device. And they would like to get it because they were just, the privacy changes in Apple has been very hurtful to Meta. So they would like to get into this market. So they're challenging essentially the like of Apple. Apple is a market mover. If Apple makes, release a device, everybody will follow. So Apple is the market mover and Samsung would be the market follower. But between Apple and Samsung, they own something like 90% of the global, smartphone market. If these two companies decide to do something in AR, it will happen. Okay, so therefore, we're waiting for Apple to release something. Rumors are ripe that something is coming out to be confirmed. And of course, we're working with all these players to make sure that we connect all that solutions well to the 5G network. So that's a little bit, the timeline. The question now is, how do we make it to happen technically? And I can't believe I'm saying this, in 2023, because as academics, I have worked on this. I have papers on this actually as professor at King's, on the edge cloud rendering. So why do we need the cloud? And this is really where the transport requirements and the wireless requirements come in, etc. So what is happening is that the experience, my personal experience by using these glasses, and I've tried quite a few, is even if it's 4K, the actual experience is only 2K and 2K per eye, and that's really interesting because the way how our screen experience has evolved over the last years has been remarkable in the sense that we started with the cinema, which the screen is about 20 meters away. We then invented television. It was then about 2 meters away. We then invented smartphones. It was maybe 20 centimeters away. And now we have these augmented reality glasses, which is, 2 centimeters away. And by the way, I've tried already augmented reality contact lenses, which will be something like 2 millimeters away. So we're getting closer to the eyeballs, and therefore the resolution we need to get that same experience needs to increase really, because our eyes see the content now much closer. So therefore, with 4K glasses as we have at the moment, it's 2K and 2K. It's half of the resolution I effectively get from my phone. So we can't expect 1 billion people to migrate to something which, from an experience point of view, is so much worse. So therefore, I think, the roadmap is clear. These glasses need to go to 8K, 12K, and even 24K to get that same amazing experience. The only problem is you can't really render 8K or 24K content on the glasses, and probably not even on the tethered mobile phone. So therefore, the only solution to do that properly would be in an edge cloud. In a cloud which is not very far, you have enough processing power there, so you don't have power constraints, memory constraints, or battery constraints. You just do it. The only bummer is you need good networks, okay? And what before, if you do it on the device, was kind of mobile broadband. So MBB stands for mobile broadband. Few kilobits per second, maybe a megabit per second. You get away with a very low rate. Once you do edge cloud rendered stuff, you need to get your network really in place. So this is TCC, time critical comms, megabits per second data stuff in millisecond latency. And what we discovered, jitter is more important than latency, right? So, and I'll explain you why in a moment. So the moment you do essentially the edge cloud rendering, what happens is that every frame, so I'm moving my glasses, I'm sending control data that I've moved my glasses to the edge cloud. The edge cloud now needs to re-render my Pokemon Go such that, it takes into account my movement, okay? So I'm getting a different spatial anchor, the lightning will change, so it needs to be re-rendered in real time, and that has to happen between frame, and frame. Now the frame rate has increased, the cinema frame rates were, or are still surprisingly 24 frames per second. And in the AR and VR frame rate, it's about 90 frames per second, sometimes even 120 frames per second. And that is really to avoid that cyber sickness and what the motion sickness you get when you put on these overlay glasses or the virtual reality headset, right? So we had, if you do the maths, 90 frames per second, 1 over 90 frames per second is about 12 milliseconds. So every 12 milliseconds, I need to re-render essentially my image. And therefore the round trip time for that whole solution, in theory, is 12 milliseconds. In reality, we have a bit of more time. We're doing a few tricks using AI, in fact, time wrapping, foveation, and all that for those who are skilled in the arts. So there's a lot of stuff happening there we're doing. And it turns out then the jitter is super important. Why is that? Because the as the image comes in and as the control signal comes in, it needs to be re-rendered. The rendering farms today we're using for NVIDIA's Cloud XR is super susceptible to jitter, right? So getting a jitter right is actually almost more important than getting the latency right. So that was quite an interesting insight for us, because we have actually not designed networks for jitter. We saw in 5G design them for latency, so maybe that is a kind of a design requirements for 6G. Anyway, so you get the idea. And the data rate, of course, as we go from 4K to 8K, from 8K to 12, 12 to 24, will really increase significantly. So we're going from megabits per second downstream to gigabits per second, and this is really where 6G will need to get into the play. Okay, so that's a good case now, a good moment to move over to our 6G story. What are our use cases? What's the roadmap? How do we think about 6G? And from an Ericsson point of view, we started to look at it very early. What could be use cases? And there are really like three of them: immersive experiences. You see a video there. Reprogrammable worlds, you see that. But really the main thrust are these holographic societies, we will think. You see this couple having lunch or dinner. They're physically not together, actually. They're physically apart. And, they're utilizing really these very immersive technologies to get this emotionally, a bonding lunch or dinner whilst actually physically being apart. So it seems a little bit like Black Mirror, but I think we can do it without it being creepy. And, that's what we're working on, really, from a device point of view, from a network point of view, and of course, from an application point of view. Right. So, and what does it mean technically, right? So if you look at it, if we start from a bottom left corner there, what we really want to do is whatever we do from a tech point of view, we want to make sure that 6G will really support these use cases. Okay, that's really the narrative. We want 6G to support these use cases. And therefore, to start with, we really need limitless connectivity. Now, we've been promising that, since 2G probably, that, connectivity will get better and better and better and better. But, we are there now. So it's to the point where if you have 4G or 5G, I have 4G, 5G almost in all places where I am, which is really great. So still some areas not covered. So we therefore started to work with satellite industry. It's called NTN, non-terrestrial networks. We need more spectrum. We need new radio solution, new massive MIMO, new inventions around really wireless, and that will be the blue box there, limited connectivity. Now, the next thing we figured out is that the telco industry has been very ARPU centric. So meaning, it gets money when you sell SIM cards, and this is not how the application industry works, right? So the application industry really works on, you make money when you do an API call, or when you use an application, etc. So it's a much more, development application centric than boxes and cable centric, like we have in the telco world. So what we really want to do is we want to reinvent the network compute fabric. Okay, that's what we want to do. Make it much more developer centric, and come up with an API centric proposition. And Ericsson is actually quite serious about this. It's a bit like playing the lottery. You have to say, we don't know whether it will work out. But we did acquire a company called Vonage for a whooping $6 billion the other day. And Vonage is an API company in essence, which provides, communications as a service. And we acquired them because we really believe in that ecosystem. Now, as I said, it's a lottery. Our lottery ticket was quite expensive, $6 billion, but we believe in that. And really the market started to listen. And we hope as a company, we can really spearhead that completely fundamental change in telecoms. Now, the moment you have a lot of, different heterogeneous connectivity technologies and you have a lot of APIs, you will have a huge amount of degrees of freedoms, right? So there's no way a human can manage that, which is why, the introduction of AI is absolutely instrumental. So, cognitive networks is really the bread and butter of the future of telecoms. And we use quite advanced tools already today. Of course, as the telco industry, we're always, a little bit behind. So I don't think anybody is using ChatGPT to design their networks today. But we're using CNN's convolutional neural networks to really make sure we get the right heat maps, traffic predictions, and anything which relates to kind of spatial data to be analyzed. We're using RNNs, specifically the LSTM embodiments, to do time series prediction, which is quite useful to us at various stages of the network. Whether that is a long-term prediction to be able to predict how we need to, change the tilt mechanically or electronically, whether that is a resource management issue, whether you want to predict, congestion or liberation of networks, whether you want to predict that there's a security incident. So we're using these type of tools. Interestingly, we're also using GAN, so generative adversary networks, again, to predict, to be able to get real life traffic and simulate it as part of our digital twinning infrastructure to make sure, we're getting traffic as live as possible, which then allows us to stress test the networks. We're using also GNNs, so graph neural networks, to really power optimize, let's say, transmission and interference, transmission powers between different cells, such that the total interference is minimized. And as we know, the power control in a telco network is in one cell impacts all the other surrounding cells. So therefore, using GNNs is a very, very obvious way to do. So there's a whole set of more type of reinforcement learning we're using hybrid models. We're looking at a whole suite of anything you can think of which has been invented in the last years is part of our commercial offering. Right now, the issue now is that AI, as we know, doesn't really behave properly. And in fact, I'm talking to the preached crowd. I'm preaching to the converted crowd in a sense, because that whole notion of trustworthiness was, as far as I can tell, really invented at King's College London with Maria and Derek, and then Dan Magazzani continued that, and I hope this is still going on. Dan now left King's as well. All of them left industry, actually. So I hope this is not a pattern really there at King's. But anyway, so the trustworthiness really needs to be built very deeply into this. And actually, Ericsson recognized that very early on. So here you go. So that's our journey a little bit. These four technology boxes are really needed to make 6G happen. Now, in terms of the actual roadmap, how this will look like, I'll be very quick on this one. So in 5G, we really talked about this famous triangle, and we're using these acronyms. We're a very acronym-centric industry, and they're unpronounceable. They're probably more secure than my passwords, to be honest. So we have EMBB, which stands for Enhanced Mobile Broadband, URLC, which stands for Ultra Reliable Low Latency Comms, and MMTC stands for Massive Machine Type Comms. So EMBB is all about watching Netflix better and quicker, whatever you want to call it. URLC is all about connecting your robots and industrial sensors. And then MTC is really connecting loads of sensors in smart cities, right? Now in 5G Advanced, which is now coming up, we will improve these vertices. It's going to get a little bit better, but 6G needs to fundamentally change. So we still keep, the three elements there, but we're introducing these yellow ones, right? So really introduce compute and AI natively in 6G, make it very immersive. And also, a really interesting technology is to have both comms and sensing at the same time, which we need for this volumetric capturing we talked about on the digital twinning. So this is how we want to do it. And from a leadership point of view, we have started to build it already. So I just came back from Mobile World Congress, and I just wanted to show that to you. We had a 6G stand, which was, beautifully done, almost like in a spiritual environment. It was very dark in the dome and with the right lighting there and with the nice music. And there were 4 stands really on a big round table. There's digital twinning, there was centrometric range comms, and there was zero energy joint sensing and comms. Really interesting, actually. So we work with MIT to have a clothing which has sensors built in and a radio which is scavenging RF energy. So we're really operating at 15 nanojoules of battery. There's no battery, actually, just, we're scavenging the energy which is around and then sensing the environment and just transmitting that. So that was a really nice demo. But to me, one of the interesting ones is the big one I show you is a Subterra 6 gig comms demo, which where I've seen 100 gigabits per second data rate transmission, right? So 100 gigabits per second, oh my God, we haven't seen that on a wireless link. So that was really fascinating for me to see. Now, how is the industry going to move now? So we have, things aren't being done by individual companies. Our success of the telco industry is that we work all together. And from a technology point of view, actually, we don't talk in generations, we talk in releases. And these releases come out every 18 months, typically tens of thousands of pages of standards documentation done within a group called the 3GPP, where thousands of companies meet every few weeks to churn out these specifications. And 6G will really start in earnest with release 20, when really we'll do study items there. And maybe some requirements will already be done in release 19. So release 18 and 19 is 5G Advanced. release 20, 21, 22, and maybe 23 will be release 6G. Okay, and towards the end of this decade, we hopefully can have the commercial deployments. Now, at the same time, we need to do something else, and that's done in the ITU. We need to make sure there's enough spectrum. So in the ITU meets every 4 years only at these World Radio Conferences, and there's where they decide, hey, what type of spectrum to sideline, and how to use it. And there's a bit of fatigue now among the regulators, including Ofcom, to sideline more spectrum. If we don't get more spectrum, all that vision I showed you, you can forget about this, because we will struggle with the data rates. We've done all that analysis, and we are pretty confident that if we don't get more spectrum, that whole immersive society will fall apart. So therefore, the regulators around the world will need to meet at the end of this year in Dubai in November at the World Radio Conference and really say, okay, we're gonna at least propose a certain amount of bands for 6G, and then these will be studied over 4 years. And then in 27, a decision will be taken. Okay, we can assign this band, this band, and this band. This goes back then to the regulators and national regulators, and they will auction the bands, right? So this will happen from a spectrum point of view. Importantly, I put in here, we need to avoid fragmentation. There's a lot of geopolitics going on at the moment, and it doesn't help us from a telco point of view at all, because the success of telco is really we've built a truly global solution. Today, I can buy my mobile phone in the US, buy the SIM card maybe in Canada, I'm traveling in South America, I'm calling my friend who's Australian, bought the SIM card maybe in Jakarta, is right now somewhere tracking in the middle of Africa, and we can talk, right? So this is really phenomenal. It's a global technology, and we don't want to split it up. So therefore, apart from technology, apart from spectrum, we need to get the geopolitics right. So I just want to mention that because it's quite important. So let me spend the last minutes on some technology policy challenges. One is really around spectrum. We really need that, what we call that centimetric range type of spectrum. So this is will be called frequency range 3 from 7 to 15 gigahertz. Why is that? Because that gives us the right coverage and the right capacity. So we have learned that the millimeter wave we've done in 5G, 26 in Europe and 28 in the United States, gigahertz is great for capacity, but really lousy from a coverage point of view, actually worse than we thought. And in fact, it is so bad that 2 mid-band base stations, properly deployed, give as much capacity as 10 millimeter wave base stations, right? So therefore, we don't want to fall back into the spectrum trap. We will need these higher bands. We need millimeter wave, we need the sub-terahertz range. But for very, specific deployments, whether it's in a stadium or in Waterloo, Waterloo Station, whatever, there's a lot of people. But generally, if we want to serve society widely, we need these centimetric ranges. So we need to get that right, okay? We also may need to rethink a little bit auctioning, net neutrality, system coexistence. There's a lot of AI in there, which can really help us for different systems to coexist. Huge challenges, but really spectrum is at the very essence of that. And therefore, we need to get that right. The second one is really all around AI. We have built now AI solutions really deeply into the telecom stack. We are now at the point where we think that these systems can start to become self-aware, sentient, kind of self-designing, self-learning systems. And this is an inflection point where we really need to understand, how do we build in that trust and this explainability in there? How do we make this work with all these new technologies? Just as an example, if somebody was to ask you why, the transformer large language models, the LLMs, came up with a specific response, you wouldn't know. Okay, so how do we bring that trust into that sentient type of technology which is emerging? I think we need a lot of technology solutions there, but we also need a lot of policy solutions there. So we need to work together on that. And I will never forget that moment. I was in Stanford the other day, and that was well before ChatGPT. That was in spring last year. And there was a panel of, the latest and greatest professors from Stanford, from Berkeley, NVIDIA, and they presented their tech work, and everybody was applauding, and we were like, it was the era of the nerves, so the neural radiant functions. So they were presenting all that stuff, and everybody was applauding and were quite happy. And then the fourth speaker, interestingly, was a medical professor, a psychologist, a world's leading psychologist from Stanford. She stood up and she said, "Hey, guys, you know, I'm not sure that I'm using the right lingo, but she said, you're crazy for what you've been, what you're doing and what you're normalizing. So as a community, a tech community, we need to learn to really normalize that stuff properly with society rather than just between us, where we are kind of racing with publications against each other. And then therefore, you know, that trust really needs to be built. And I think that's hugely important, and that's really your responsibility. My last slide is really on this privacy by engineering design. I've started working on this when I was at King's. You know, I always maintained, you know, we talk privacy by design. I think this is fake privacy by design. I really don't understand the concept, to be honest. You know, privacy by engineering design, I understand that. And you will understand if I explain you what is security by engineering design. Security by engineering design is we put security at, you know, layout 1, 2, and 3. Everything is encrypted, right? We're using encryption at every single layer up to the application layer. So this is really an engineering design. Privacy today, whether that's privacy or privacy by design, is always the T's and C's we still have to tick off. If you want to use Google Maps, you need to agree to their terms and conditions, right? And then you have to trust the company. You don't know what Google is doing with the data. You don't know what Meta is doing with the data. They claim one thing and maybe it's something else. So when I say privacy by engineering design, I mean that we need to build in privacy mechanisms deeply into the engineering stack, layer 1, layer 2, layer 3, such that it preserves privacy of you know, the people who are involved there. So, and an example I give you, for instance, if we have augmented reality glasses on, we're taking volumetric point clouds, or even filming stuff, or we're taking selfies in this new immersive world, you know, you will have people in the background or in the foreground now. They have no idea they're there. So, you know, the privacy by engineering design should make sure that we are, you know, either blurring these people or we are replacing them with different faces, whatever, you know, that we are very creative on how essentially technology, AI as an example, you know, GANs could be quite useful there. You know, how is it natively action taking, making sure that, you know, the privacy of what everybody around is really preserved. So I think we need more work on that. We need more academic breakthrough on that. We need, and then the industry can take this over and build it into our product stack. But I thought I'd bring it up because I think it's hugely important, and it has some pertinence to the work you do, guys. Okay, and then with this, I'm really done, you know, and I'm happy to take any questions if you want to. And otherwise, I wish you a good afternoon back there in Europe and in London.
Thank you, Misha. Wow, what an excellent summary of the industry state of art and the work that Ericsson is doing, but also really fascinating how it puts into context everything we discussed this morning around security and AI methods, including some of the more innovative things like physics-informed neural network for capacity planning. So really interesting. Thank you so much for joining us today. So, do we have any questions from the audience? Please raise your hand. Paolo, I think you could unmute yourself, I believe. Yeah.
Thank you very much for that excellent talk. I really appreciate. Okay, I'm keen to see the new glasses for sure. I have one from the Bose, only for audio, and they are excellent. They are quite immersive, and I want to see new versions. Okay, you talk about the scarcity, about the spectrum. Okay, you talk about using sub-terahertz frequencies. What's your opinion? You're using free space optics or Li-Fi or this kind of
So Li-Fi free space. So free space optics for us is super interesting for the front haul and the back haul, right? The moment you don't want to lay fiber and you just need to bridge a little bit of a distance, could be last mile, could be something you know, before or after. So that will be hugely important. Now, Li-Fi is a different construct altogether, right? So we're talking about really putting in the pulps here and really making sure we get the transmission going. In my opinion, it's more a Wi-Fi construct. So it's probably more an IEEE type of technology. What I would like the community to do there is to actually implement it natively with the 3GPP, so the 5G and 6G standards call flows, right? And today, actually, the 3GPP community has done that, okay? They have done that with Wi-Fi. So Wi-Fi calling is possible because we as a community made it possible. So today, when you arrive home, there's a native handover to the Wi-Fi technology. But the moment you leave, your home, Wi-Fi is not automatically handed over to the cellular. And the reason is because the IEEE community hasn't done their homework. So if I have a request to the Wi-Fi community, please make sure you build the right call flows and stuff in place so we can have a native handover between 3GPP type of cellular technologies and the home Wi-Fi or Wi-Fi technologies. Yeah.
Thank you.
Thank you. Do we have any more questions?
Yeah, we're good. Okay, all exhausted.
Oh, sorry, we actually have one now. We're still going strong. We still have people rising.
I can tell. Well done. Yeah, you deserve a good glass of wine after this. I would like to give you some Californian wine, but I can't anyway. Yeah, Kinza, tell me.
Hi, thank you so much for the talk. I'm actually a student at King's at the moment. So my question isn't going to be super technical. Okay, it turned on. My question is not going to be super technical, but I thought it was really interesting when you said that we kind of need to democratize all of this to like the greater public. And I am in that field in the sense that this is what I'm studying, and this literally sounded like sci-fi to me. So I definitely agree with that point. So I was just wondering, like, how could we actually do that? Like, how do we democratize, and how can we do it as people that are studying or like working in this field?
So I think it's a hugely important work. Area of work. So 20 years ago, I wouldn't have said it, but being where I am now, I can really recognize that whatever you do, Kinza, will be hugely instrumental. I think there's a very, very strict, a very strong technology question there. So as an example, we're designing this now for this very immersive society. And of course, these glasses will not be cheap. The 5G and 6G technology will not be cheap. So the big question, we need to ask ourselves is, do we empower now people in countries where maybe, technology isn't moving at the pace as I see here in Silicon Valley, or as we see in Central Europe. So, and then the bigger question is, what do we need to do from a technology point of view so we can still offer that as a minimum kind of denominator? So we are not leaving out these 2, 3, 4 billion people with actually this type of technology. And, the answer to that in the internet era was actually almost kind of a charity approach. So if you think about Raspberry Pi has somehow democratized computing, right? So it became affordable in loads of communities around the world where this hasn't happened before. So we need kind of a Raspberry Pi moment for AR and VR and for computing and for networks. And maybe, you should talk to Eben, he is 20 miles or 50 miles up living in Cambridge. He's a founder of a Raspberry Pi, is a good friend of mine. So maybe you need to talk to him and really figure out how could this be done from a tech point of view and inform us as a community. The other point is also the other point is then the policy side and even just the informing side. So interesting, when I was still at King's, I dealt quite a lot with a few user engagement groups and consumer engagement groups, I think they're called. And I think you should reach out to them and really talk to them about privacy, usage of technology. I can't promise if I still have access to some of my emails at King's, but maybe I can find the names for you. There's some really good names in London dealing with precisely that topic. So if you tackle this from these two angles, I think there are a lot of, and from the policy point of view, what the government should be doing, and I'd be happy to introduce you to the respective Ofcom folks there. If you find that triangle, I think that would be a very interesting, masterpiece or PhD thesis you can work on. Yeah.
Amazing. Thank
you very much.
I love the energy. Things are happening straight on the call, connections and a new project starting. Amazing. Thank you. Bo, do you want to ask a question?
Actually, I do not have question, to be honest. Like, I just want to say, like, thank you very much, Misha, for attending our Duo project events. This is actually our first events after 1 year of the implementation of the project. And thank you very much for your excellent presentation with huge amount of the new information. Probably I need a certain time to digest it and to come up with a meaningful question. And I may just, if I have something in my mind, I will probably drop an email to you.
Just to
Okay.
mention, we have been recording this, so it will be available online if no one objects of being online and distributed. So definitely we'll have opportunity to rewatch.
Brilliant.
Okay.
All right. Thanks, everybody. Take
Okay.
care.